Hi guys, here we are looking at the rest of section 3.3, Algebra 2, and this is our part 2 section. We only have one problem to talk about today, or here, and that problem is this one, example 4. We're going to find the vertices of the following picture that's formed, or the image that's formed by these particular inequalities. And so you see I've highlighted them in certain colors and I'm going to graph them. We've been graphing inequalities for a little while from the last video, so I'm going to try to do these quickly. Let's first do the red inequality. When solving for y, this is what we get, and when we finally graph it, this is what we get. Next, we'll take this blue equation, or this blue inequality rather, and we will organize it so that we can graph it easily. So we get y is greater than or equal to x plus -6, and then when we graph it, we get this overlapping area that we see part of our solution is right here. Now finally, we've got to do this green equation, and I'll take this equation and I'll solve for y. There, after solving for y and graphing it, I get this triangle here. And what we're asked to do in this problem, if you don't remember, we're supposed to find the vertices of the figure formed. Well, we see that we have a triangle and we need to find the vertices. This seems simple, but if you notice, my graph isn't that great. To be quite honest, it's horrible. And so in order to find those vertices, what I'm going to have to do is actually find the intersection of two lines. You guys remember how to do it, right? We just did it in section 3.1 and 3.4. I mean 3.1 and 3.2 rather. What we did is we found the solution of systems of linear equations, and that's what we'll do. So we need to do it for every pair of lines. So we need to do it for the red and green and the blue and green and the red and blue. And that's what we'll take our time and do down here. So in order to find these intersections, what I'm going to have to do is take them as pairs, like take each equation, the related equation to each of the inequalities, and figure out what their, whole situation is going to give us, what their intersection is going to be. So I'm going to be not lazy, but I'm going to be resourceful, right? And I'm going to copy this and then take these two equations, and I'm going to find the intersection point of the green line, of the blue line and the red line. And so what I'll do, I don't know about you, but this looks like a great candidate for elimination. So I'm going to add these two equations together. Remember, elimination, we decide on a variable to get rid of. We make sure that the variable has a coefficient that are additive inverses. And since y is, the coefficient of y is +1 and -1, those are additive inverses. That works for me. I get that 2x is equal to a +5, and therefore x is equal to 5/2, which is 2.5 or 5/2 or 2.5, right? 2.5 or 2.5. And so now what I'll do is I'll take this value and I'll plug it right back into the equation. Let's say that first one. So I have 2.5 plus y is equal to -1. And with a little bit of mathematical maneuvering, we can see that that's -3.5. Take a breath, make sure it makes sense, because you know I make mistakes. So y is equal to -3.5 when x is equal to +2.5. I'm going to put that right on my graph. There we go. Next, let's go ahead and take a look at the intersection of the green and the blue equation. Okay, so this should be a 12. So the elimination method, we're not quite set up for elimination method here, though we could do it. Notice that the x and the y terms are not lined up accordingly. So I'm going to rewrite this a little bit. If I put a -y plus x is equal to 6, and then a +12y plus x is equal to 32. Now maybe elimination method might make more sense. What I need to do is I'm going to eliminate the x. I'm going to multiply the top equation by -1, and I'm going to add everything together. So -1 times a -1 times a -y is a +y plus 12y gives me 13y. Stay with me. -1 times x is a -x plus a +x gives me 0. Elimination. Then 6 times a -1 plus a +32 is going to give me a +22, right? No, not really. If you're shouting at the top of your lungs, it should be 26, you're right. So it's going to give me a +26, which I like, because beautifully, when I divide both sides by 13, y is equal to a +2. If y is equal to +2, I'm going to take one of my equations, let's say the first one, I'm going to put 2 in for it, and I'm going to calculate what the value of x is. From this, I can see that x has to be 8. So my point here for this one, the intersection of the green and the blue equation would be 8, 2. So I'm going to put that right up here, 8, 2. All right, and finally we've got one more to figure out. That's the intersection of the green and the red equation. So we grab those two and we turned it around so that we can have everything lined up, y's over y's, x's over x's. And what I realized is I think I'm going to get rid of my x again, right? So I'm going to multiply the first equation by -1, and when I do that, I'm going to get the following. I get this times -1 times y gives me a positive 12, I'm sorry, -1 times y gives me negative y, add 12y, and I get a positive 11y. Here, these guys are going to cancel out, and here we get a positive 1, which is equal to 33, right? Because a positive 1 plus 32 is 33, which makes me happy again because it looks like I'll get a number that feels like it works out well. Y is equal to 3 in this equation. Now, if y is equal to 3 here, boom, I'm going to plug 3 right into that equation and figure out what x is. When I do that, I calculate that x has to be equal to -4. Notice if I subtract 3 on both sides, I get a -4. So let's see if that works out. -4, positive 3, -4, 1, 2, 3, 4, positive 3. Nice. And that was like the only one that I could really confirm that worked out. And so I know that problem took 6 minutes to you, but a lot more to me because I had to pause it and do the work. But that is what is expected of you when you have to do these problems. So they are involved, but they're really going to help us lead into the next section, which is linear programming. If you have any questions or comments, let me